All right, this time I moved the chair before I started the video, so you don't have to listen to that. So we're finally on to the last part of the question, which is what is the probability that the kid is going to be a carrier? And I feel like this is what confused a lot of people. It confused me. I was one of the people that answered 2 9s, and it's because I didn't consider them as two independent events, e.g., mutually exclusive, which is just a bunch of terminology, but essentially just means if, and add together the if, ors. So let me walk you through what I have on my board here. So I went ahead and just labeled up here that we have 1/12 the kid is affected in case you just forgot from the last one. But I'm going to break it down. So we know that the dad has two possibilities. He can be heterozygous or he can be double dominant. Now we know the mom. The mom is going to be heterozygous no matter what. So I broke it down into two events. If dad is double dominant, kid has blank chance. If dad is heterozygous, kid has blank chance of being a carrier. Now I feel like something that confused people a lot in class 2 was the terminology, because they asked why we didn't include the double recessive in there. It's because they specifically say carrier. So I have up here labeled my circles for my Punnett squares. So we have affected and unaffected. So that's going to be our double dominant, double recessive. And then we have our carriers, which are always going to be heterozygous. So they're essentially asking you if the kid is going to be heterozygous. But back to the problem. So we have if dad is blah, kid has blah chance. If dad is blah, kid has blah chance. We go over here and we do our crosses. If dad is double dominant, we cross it with mom who is heterozygous. We get, with the Punnett squares, a half chance. If dad is heterozygous, crossed with mom who is heterozygous, you do your Punnett squares. You get 2/4 chance because you can't include the double dominant and you can't include the double recessive. So there's only 2 possibilities out of 4 possibilities that the kid is heterozygous. So you get 2/4 or 1/2. You go back down to your problem here, treating it like 2 different events, which means we add them together. We do not multiply, which is the mistake I made before. Dad is AA. We know that he has a 2/3 chance of being AA, double big A's. And then we know that the kid then has a half chance of being a carrier. If dad is heterozygous, we know the kid has a half chance of being a carrier. So we have our values from before, 2/3 down to 2/3, 1/3 over to 1/3. Add these two together. You get 1/3 plus a sixth, and then you do a bunch of fraction simplification, and you get all the way down to 1/2. So the kid has a 1/2 chance of being a carrier. I hope that made sense. It made sense to me after I thought about it, so I thought I would just share these with people who are still confused.